Hello, everyone. My name is Zane Everett, and today we're going to be talking about dots. This is Unity's performance by default framework. This will be a light overview of everything that they are doing. I hope everyone is doing all right and have enjoyed their SimFest. Going to get started. So my name is Zane Everett. I've been a Unity programmer for over 9 years now. I've shipped over 21 educational titles. I'm not going to go through the list of everything that I do. The thing I am going to talk about in a little bit more detail is my work at Motion Reality. And if you guys have seen the 2018 Siege talk by Sean Shepard entitled Real-Time Multiplayer Games, that was a couple years back, Sean talked a lot about the work that was being done at Motion Reality. Essentially, Motion Reality was creating some mocap VR, location-based reality stuff that was very unique, very interesting, but some of the deal with it is it had to be extremely performant. And in that talk, Sean talked a little bit about the ECS framework that was developed at Motion Reality that was auto-networked. And if you're not sure what ECS means, that is some of what this talk will cover, so that will be explained shortly. But what I'm saying here is that I have had prior experience working with some of the portions of the DOTS framework prior to Unity announcing DOTS. And so I have this great transitional knowledge from where ECS kind of started and how Unity picked it up and started applying it to DOTS. Beyond that, I'm the regional coordinator for the IGDA US South. This is a new position with IGDA that is designed to help HQ kind of manage more of the chapters around the world, because there's over 120 chapters. I'm in charge of chapters from as far north as like Virginia and Kentucky, all the way to the west to Louisiana, and bounded by the ocean. Additionally, I'm the vice chair for IGDA Atlanta. I've been in that position for 2 years now. I've been helping organize different events. If you want to find out more about IGDA, you can check out igda.org. There are plenty of benefits to being a member, between Unity discounts, some significant Dell product discounts, and things like insurance for health insurance, for a couple of different types of insurance if you're in the game development space, as well as just tons of resources if you are interested in getting to game development itself. So beyond that, let's get into the meat of this topic. Unity DOTS. What is DOTS? Well, it stands for the Data-Oriented Technology Stack. So this suite of packages that Unity has come up with is they want to present a format for creating games that are performed by default. So that means that it should not be difficult for you to make games that just run, that you don't have to worry so much about optimization. If you've ever worked with virtual reality or mobile development, optimization can be a headache. It is one of the biggest pain points of creating your game, especially if you're new to it. The biggest challenge to creating those types of games or software is that if it's your first time, you typically just go for it, and then you realize that you need to go back and optimize, and that takes almost as much time as your initial development. Once you've had some experience, you go, oh, I should optimize at the beginning. Well, it's kind of taking that experience of you need to be optimal at the beginning that Unity is trying to make simpler for us. So it is comprised of 3 packages. If anyone is unaware, packages are Unity's new method of delivering new content beyond the larger editor extensions. There are tons of different packages. DOTS is composed of 3 primarily. The first one is jobs. And jobs are a method for creating multi-threaded code. It does it so much easier. If you have ever had to create a multi-threaded process on your own, you know that you have to go through a multi-thread process and a synchronization process, and you have to manage that on your own. Unity is doing something neat with jobs in that the entire process of your application is broken up into essentially 3 parts: a pre-synchronization step, a multi-threaded step, and a post-synchronization step. This stuff takes the requirements of you having to manage synchronization through multi-threading out of your responsibility. It is unburdening you from the task of having to manage this, and that was the largest headache having to do with multi-threading. And we all know that multi-threading makes stuff run faster. The second package to this is Burst. Burst simply takes jobs and kicks them off to the GPU. And if you have looked at any type of research about doing stuff into the GPU, GPUs are designed for multi-threading. That's what they do. It's how they render our graphics and present it to the screen. Having the process made automatic for you is awesome. So the final portion to this is ECS. This package allows for a way to write code in a way so it's organized so that it works better with multi-threading. And with these powers combined, like, it gives you performance by default. And ECS a few times. ECS stands for Entity Component System. So what exactly does that mean? So this is a data-driven design format where it's different from object-oriented programming. Like, we're all pretty familiar with object-oriented programming. Data-driven design takes some of this and flips it on its head. Through object-oriented programming, we typically use inheritance as a way to get complex behavior. Data-driven design says no to that. It has a very flat inheritance hierarchy and instead favors composition, so that the data of different portions of whatever you're trying to represent, when combined, drive what the program is supposed to do. So an entity is simply, at least within Unity's context, is simply an index that has a collection of components. That's it. So components are simply data. And your system are the methods that impact that data. So if we talk about object-oriented programming a little bit more, you guys often know that data and methods are put together. With ECS, that is a no-no. You never ever have methods in your data. Covered much of what I talked about before through this slide, but what we can cover with some of these images. So we have on the left-hand side here some object-oriented programming and how, like, different game objects is what these in the image here. That is what some of these individual blocks of objects are. You can look at each one of these blocks as individual components, and you can see the execution of those things is kind of all over the place. They're being run at different times. A data-driven design that allows it to be multi-threaded is that it pairs up a lot of this stuff into individual processes by gathering up all of the data and shoving it into the CPU or GPU as one collective bit, and that is what allows multi-threading to happen. Design philosophy that I didn't talk about was that with object-oriented, we often look at abstraction. If we think about, like, animals, if you were to try to create some type of animal within your code, you would typically start with, well, an animal, and then you would list out the different functionality that would have, as well as the different data, and then say, okay, I've got my animals, and I need a bird and a horse, and those can be divided into, well, bipeds that also fly, and quadrupeds, and those are going to behave differently, and so we would create different classes for those, with the specific data for them. But then, a horse is different from a cow. And so we make a specific instance of cow and put in additional data and methodology that describes what a horse is as opposed to a cow. For data-driven design, you don't start with abstraction. You start with the concrete thing that you're trying to do. There are commonalities among all of animals. They eat. So you would likely write a set of data that describes, eating, hunger, things along those lines. If things that are land animals all typically have some type of movement, and so you would describe like their speed and stuff like that in a separate component. And when you combine those different types of components that describe what the type of animal that you have, potentially even like a horse tag, those things define what a horse is, and you can have individual sets of methodologies that only apply to that. And you don't have to worry about abstraction, because if you've ever done this in practice, you can get very web-like inheritance structures, and they can be hard to follow and debug, and it becomes a nightmare beyond the savings that we have for performance. And so memory usage, not just your performance speed and all of that. When we do object-oriented code and we create a class and we put tons of data into that structure, and we try to reference that structure, and with it, we have to load everything about that class inside the memory. We have to take it from whether it's main memory or level 1, level 2 cache and shove it into the processing unit. And the further away from the processor that memory exists, the longer amount of time it takes for that memory to get into the processor, and it takes up more space within the processor, thus slowing everything down. Through a data-driven design approach, the only thing that you care about if you're going to do something like modify a transform is the position. So why are we grabbing all of this additional stuff that we don't care about to try and put it into the processor unit when all that we really need is the vector 3 for position? So data-driven design allows us to smash all of the vector 3 positions so that we can modify it for a transform into the processor all at once without having to worry about the excess data. These are the two elements that speed up the processing of different functions, and which make ECS and dots so much more powerful, and why if you've seen any of Unity's examples of stuff like this that have like the cities environment or the large RTS, how they can just have so much stuff on the screen. I also want to point out this isn't just Unity. Like Overwatch was written in an ECS format. They were one of the early adopters of this, and these are the reasons why, because they wanted high processing, particularly for them, it was for networking. Adopted this strategy for you to use. So from here, I'm going to move into a live demo. I'm going to cover a handful of things in this live demo. I'm going to talk about the package manager if anyone has never seen it, because that is how you access these initial tools. Unity has a handful of new tools for you to use specifically with ECS, and I'm going to show that off. Then I'm going to give 2 code examples where we talk about spawning and modification. Once you get these 2 items down, that's really the majority of like game dev. I want to make things and I want to move them. There's more stuff to it, but most things kind of come from this. I think the last one that I'm not going to show is destruction, but there's a very similar process to spawning. If we have time, I'm going to go through a handful of editor tricks. So let's move from here into Unity. If we got technical difficulties on my machine. Loaded to show off. I prepared this for you guys because I love you. Very interesting. We're here, and this was the deal, but it should tell me that this is already open. Let's try just closing it. Right? That was the deal. I had all of this prepared for y'all. You can see it's like trying, not quite doing it. So let's task manager that, and Unity, let's end you. And the city builder, because that's where we're at, and yeah, don't know what's up, but we're able to continue, hopefully.
And we are back.
Hey, I apologize for the technical difficulties, but you know, I'm doing this live and live stuff happens, and I had it open and ready for you guys, I promise. So let's take a look. My collapse things for showing off what we were specifically going to talk about are no longer there. This is there we go. So here we are in Unity. The first thing we're going to talk about is the package manager. And so if you're not sure where to find that, you're going to go to Window, and you're going to come down to the package manager right here. You're going to open that up, and Unity is going to give you this full list of packages that you can download. Some things are that have traditionally been part of the in-game editor have been moved into its own packages, such as the Unity UI. But the main things that you're going to want to download, it's 4 individual packages for this. You are going to want Burst, and you can either update or download the stuff. I'm not updating because I don't know if it will break anything presently, and I want to do that after this demo. So you're going to get Burst, and that gives you the Burst stuff. You can go for the dots editor, which is going to give you a handful of additional tools. You want entities. Lastly, you want jobs. And since we're in here, I'm going to point out a couple of other dots-related things that are somewhat new. So right here, we've got 2D entities. This builds off the current entity stack, ECS stack, and so that you can do specific 2D stuff. Unity has also so that we have dots physics, and interestingly, that also works with physics, or Havoc physics for Unity. And the last bit that you may or may not want, is kind of important, is the hybrid renderer. And so this takes a lot of the things that we're familiar with as far as rendering and puts it into a dot stack. So those are a handful of packages that I would recommend if you are wanting to start working with dots. So once you have those downloaded, they're going to show up down here in your packages. We can see I've got addressables installed. There's entities and hybrid render and jobs, and you can see that this is where they begin to live. What we're going to do after talking about the packages is I'm going to show you what this specific example does. Let's close out this stats so that we can see more. And as you can see, I've got an incredibly simple running right here. And the biggest thing we want to pay attention to is this bamboo underscore ECS. And so I'm going to hit play, and you guys are going to get to see what this does for this example. So what we have here is this bamboo that is growing, and when it reaches its full height, it creates another bamboo. And then after so long, it makes more bamboo. We have both of them making the bamboo, and so on and so forth. So essentially what we're doing is we are manipulating the scale, and we are having new things spawn. And this is going to be the two things that we give as an example. Going, but that should be sufficient to kind of explain. So let's check out our bamboo. As you can see, this is incredibly similar to the whole game object process that you're familiar with Unity. There's a handful of unique differences. The first one being this object has this convert to entity check, and if you toggle this, you get this additional component. This component does exactly what it says, and it converts this game object into entities. I want to point out, because Unity also very much points this out and make sure that people know this, like game objects and entities are not the same thing. Entities are virtually nothing. They are an index that have an array of other components associated with them. That's it. Your game objects have a set of mono behaviors on them. And right now, this is a game object. And you can see that my conversion mode here is set to convert and destroy. I can also convert and inject. An example of convert and inject is the main camera here. I've got it set to convert and inject so that it maintains here and I can see everything that's going on like normal. So this convert and destroy, as soon as I hit play, the first thing that happens on, except it's not, it exists here in my scene still. So what's going on with this? Let's pause it and let's show off the brand new entity debugger. So the first thing I'm going to point out is that bamboo that we had initially and destroyed, there it is as a single entity. It has been converted with all of the stuff that was on it into ECS components. So for this entity debugger, let's pause for just a second and show you where you can find that. If you go into Window and down at Analysis, right here we have an entity debugger. Now that we know that our bamboo is here, let's cover some of what all of this entity debugger is, because this is a brand new window that has a lot of information in it that is the core to the whole ECS front. What we have here in this one tab is a list of all of our entities. Let's start over there. On this left-hand side, we have all of the systems that are running in our program. You can see that they're divided up into a handful of groups. We have our initialization stuff. The stuff that I mentioned before is this pre-synchronization. We have an update loop, which is our multi-threaded loop. And down here we have a pre-laid update. This runs just before our post-synchronization loop. And so all of this is the different systems that we have running. And if we tag here, we see right here, this is all entities in our default world. But we also have a handful of other types of systems. And what we see on this middle pane is all of the entities that are associated with this system. Well, the entities is a little inaccurate. It's really a collection of component groups, but it's very easy to think of a collection of component groups as being the entities associated with it. All of the entities in my scene. And we can see here that we've got 3 bamboo. In just a moment, I'll explain where all of those come from. We've got a handful of other things that came in. On this side, these are matching chunks. These are basically the bits of memory that go into the processing unit that are associated with this individual entity. I'm not going to go into super detail here. This is a much more advanced topic, but I just wanted to let you know kind of what it is on a very base level. So from there, how are we getting all of this to work? We can see that like we've got a change for this. Our inspector looks a little bit different. This is our typical normal inspector. So if we select a normal game object, we get a game object inspector view. But if we inspect an entity, we get this nifty view. And that has all of our ECS components and the values that they have. Now, we can't modify this stuff directly, partly because we are in-game. And the reason for that is presently, all of this data is currently in a multi-thread process. And so with all of the multi-thread stuff happening, if we changed one of these values, it would throw much of the multi-threading process off. So we don't want to mess with that. Again, taking a look into what these individual components are. Several different components that we're going to look at with code in just a moment. They are based into a handful of groups here. We're going to talk about how I'm getting growing to work, which is basically the transform modification, and how we're going to get spawning to work. And if we take a look, you can see this bamboo tag. I have one of those on there, and growth data is right there. And we have some tree reproduction stuff and some spawning stuff. There are essentially 3 specific classes that are associated with creating ECS objects. Go here. The way that you create a handful of scripts that are already pre-set up for you to do ECS stuff is you're going to go to create, and you're going to go all the way down to ECS down here. And you can see that there are essentially 3 different types of classes that we can work with. We have runtime components, we have authoring components, and we have systems. So a runtime component is the actual ECS components that are going to be storing our data that we're going to work with. An authoring component is a little bit different. It's not really ECS. It is the bridge between the mono behavior and the ECS. So the specific deal where we've got the convert to entity, the authoring components that are attached to this as mono behaviors, and translating the data into ECS components. The last one was systems. That was pretty. These are the methods that are going to do stuff. So that now that we've got all of that out of the way, let's start looking at some code. To look at is our bamboo tag. I mentioned that just a moment ago, and you can notice that this is a data class that doesn't have anything in it. It is made up of an iComponent data, which is the interface used to create ECS component data. They're always structs. The reason this is empty is because this is a tag that is used to flag different systems to say that I want a different type of behavior, even though you're paired up with some other data that other systems may use in a different way. So what I talked about composition over inheritance, I'm adding new components to change how I'm going to process the data on other data components. sense momentarily when we cover the growth component. So if I had different things, and I do, I have rice in this game that grows in a different way than bamboo. But I use the same set of data to manage that. And the way that I differentiate them through the system is I say that I am concerned with things that have growth data and a bamboo tag in my rice growth system, where I say that I want things that have a growth data and a rice tag. Comes in a bit more detail. These are made up of job component system, and the way that they work is they have an on-create process and on-update process, and it's not always needed, but an on-destroy process. Those are the basics. So what you do when you make it, what you do in update, and what you do on destruction. So for growing the bamboo, adjusting the scale of the bamboo, what we are doing, this is our multi-threaded process. We're saying that on update for each of the entities within this match, I want to do these things. So here is the set of stuff that we are looking to match. We've got this bamboo tag, things that have scale, and things that have growth data. I'm going to switch back to Unity real quick. We're going to hit play, and I'm going to show you our system. Boom. Here is our bamboo growth system that we're working with. We have one object that has a bamboo tag, a growth data, and a scale. And that exactly matches the stuff that we are looking for in this. These things marked with ref, scale, bamboo tag. This is how it is differentiating what type of entities that it's going to act on. I'm doing some things based on time. I am setting a scale value, and I am adjusting that scale value. In order for us to put this off for the multi-threaded process, we're going to say we're going to schedule it, and that kicks it off. I will explain real quick what a command buffer is. So this is a way for us to do things outside of the multi-threaded process, even though we've changed some data within the multi-threaded process. So this command buffer is something that takes place during the synchronization side. We have this big long thing where I've identified a specific synchronization, but if you just say command buffer, you're going to get a whole list of different types of things. You can see this begin initialization. I'm doing this on the front load as opposed to the end initialization, which is on the end. That's all that means. But think of it as just command buffers that are part of the synchronization process. So I do these things. I'm adjusting these values. If I get a certain value, I'm simply going to remove a piece of data. And the reason this is outside of the synchronization process is because if we try to remove a piece of data, I mentioned it before, during a multi-thread process, it's going to muck things up. So Unity has made this a bit simple for you if you follow a handful of protocols so that it all just works for you. You say, cool, I want to do this specific thing outside of the multi-thread process. That is how the scale is changing on this, where we are specifically assigning the scale value right here after doing some calculation to all of the bamboo all at the same time. If we continue to let this play, you'll see more bamboo things pop up in this list. There we go. This was more so covering the specific scale. And you can see that all of them are scaling at the same time. Those that have the need to scale. Those that have lost it should have their stuff removed, but yeah. So from here, let's talk about spawning. Let's pause that. And our tree reproduction stuff is part of our spawning for this specifically. And it's made up of a handful of bits of data. we've got our growth distance. So what this is basically doing is putting a space between where the next thing is going to grow. We've got our time since the last growth and how long we want before new growths happen. And if we check out the tree reproduction system, we basically have that data, a piece of data for the position, and getting some spawn info. Because we're going to use this position that's created to spawn more trees. And so we're basically waiting for time. Right here, we are looking for a difference between two different sets of time, setting it random position for us, and then applying that position and saying that, cool, we are ready to spawn a thing. And you see that our spawn data here simply holds a prefab, a position, and a value of whether or not to spawn. You can see that this is what was set here and there. So two of those items, the other one is set within the editor. On to the spawn system. We're simply going through each one of those, looking at our command buffer, saying, cool, I want to create an instance of this, and then I want to set the values for those things initially. And we are resetting our spawn value. You're noticing some of this, but all of my code for all of these things is incredibly short. A lot of it is just extra spaces. Like every single one is below 50 lines. This system is less than 50 lines, and this system is less than 50 lines. Like, through these combinatory practices, we're able to get more complex behavior and be able to have things very succinct, very readable, and very, very efficient. So I've given you essentially what the data is doing. I feel like there may be a gap right now about what is happening between us having this game object and it just going into ECS. So I'm going to talk about that just a little bit. I don't know if anyone noticed, but if we go to the bamboo tag, you can see that on this I have a special attribute that says generate an authoring component. So this is automatically creating the authoring component that is being generated here. So you can see that this is bamboo tag authoring and bamboo tag. Unity is automatically doing this for me, and this is great when you have simple data components that you just want translated into something that can be put onto a game object and shoved into ECS. Instances that require something a little bit more complex. And I have one of those to show that was going to shed a little bit more light on what's happening under the hood. This spawn authoring. I'm doing a couple of interesting things in this that are outside of some basic info that is easy to translate. So what Unity is doing, our authoring components are monobehaviors with a couple of special interfaces on them. So this declare references prefab is saying that we are wanting to create a prefab out of whatever game object is coming in. And it is running. That is essentially assigning our object that we have associated with a set of prefabs that we want to spawn at some later point. It's putting them in memory and saving them for later. And I can show you this by the fact that if we go back to all entities, if we check this out, we can see we've got 2 and then it jumps to 31 as far as our entity index. If we jump back to all entities, you can see that I've got a 2 and a 3. And this 3 is not showing up in the other one because it has this prefab tag. And anything that has a prefab tag is not considered part of the normal process and is saved as data for later to be instantiated as actual entities that we want to do stuff with at a later point in time. So this says, cool, declared reference prefab. I want to make this a special reference prefab, and it automatically adds that. It creates a second copy of it. It automatically adds that tag to it and sets it aside for later spawning. And that is pretty nifty. The second bit to this is converting something to an actual game object, from a game object to an entity within Unity. And that's what this function does. We've got convert game object to entity. What it's doing is you are giving instructions for whatever needs to happen to change the game object that this is attached to into an entity with the correct components. You can see that we have our entity and the entity manager that we are going to toss this to. And we're saying on this specific one, because it spawns stuff, that I want to add a component to this entity. And the thing that I'm doing here is setting the prefab on it to be the primary entity that would exist on the prefab that we have listed here. This guy. And you can see in Unity that I am assigning that just in the editor. And it's these authoring components are simply converting whatever is in the Unity editor into ECS world. Let's see. Essentially, the gist of these two things. I may from time to time come up with a handful of tips that I have specifically missed, but at this point, I'm happy to open the forum up for questions. I know that I went through that really fast because I was concerned about time and making sure to get through a ton of different concepts, but I'm happy to clarify anything at this point.
Great stuff, Zane. Thank you very much. If you have questions, please put them in chat. Hiccup Interactive had one, which I think actually could do with a good bit more explaining. You touched a bit on the benefits of object-oriented versus ECS, as well as when you might not necessarily want to, when you might want things to happen outside of multi-thread. Can you touch a little bit about the decision-making that goes into when you'd want to use ECS, when you'd want to use object-oriented, and then again, same question about, as you were showing with the bamboo, when to multi-thread. Sounds like a Hamlet question. To multi-thread or not to multi-thread? Can you not hear me? Oh boy. Test, test. Test, test, test. Did I lose Zane's audio? Test, 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 test.
The deal there is that if you're not ready to use some experimental stuff in your game, don't. The first deal. A more practical side of when to multi-thread and when to not. You don't have to do an entire game in ECS. Don't. You can still use the typical mono-behavioral workflow, and it works just fine. My best recommendation at this point is if you are either having optimization issues in a certain area, and you feel like you're doing a lot of the same little stuff on objects, and that's creating a bog down. Like, for example, you have 50,000 trees that are actually trying to do something. In this case, if you have 10,000 AI units that are running around all trying to process stuff, those are great candidates for doing multi-threading. That's going to be your biggest optimization pain point. Other stuff where it doesn't matter, like your GUI stuff at this point isn't going to be in ECS land. It's just not. He's not ready for it. And GUI stuff really isn't a good candidate for doing this. It works on an event-driven system, or at least it does best. And that's not what ECS is. It's not event-driven, it's data-driven. So is a little bit of an explanation there. So you're looking for optimization, looking for stuff that you know can be multi-threaded, but you're not looking for your GUI. Like, and though there are ways to optimize your GUI, it's not right now a candidate for ECS and multi-threading. There's more to it.
All right. Well, we've got a question in Twitch as well. Nick Winters has a couple. Is each entity done in its own thread? How do you handle the case when entities rely on data from other entities and that data may get edited?
So, this is part of the deal with multi-threading. That can't happen. You can use that data in the next frame, but you can't use the maybe lying there. Now, if I think about it, like, you're not going to modify that data by someone else in the same frame. That's not going to happen. In fact, that's already part of the process in this. Like, that's really good. I'm going to go with, like, you shouldn't. I'm sitting here rolling in my head. There are different situations that you could do things like. That's not really what's going on. Like, an individual entity itself is not modifying the data. It's never going to do that because there's no functionality on an entity. There's no functionality on a component. Functionality is on a system. The system already has all of the components that it is going to modify. You're looking at this in a kind of linear way, but really what Unity is doing is kicking this stuff off into a multi-thread process, and it's all going to process and then spit back results at the end. And so you're going to have next frame stuff regardless. You're definitely not going to destroy component data the same frame. You're definitely not going to create new data in the same frame. That's going to be in the same multi-thread process. That's going to be done in the synchronization side. Like, all of this data should be, for the most part, dependent. There is a way to specifically. It's still here. This was early on. I can. There are a handful of different attributes that you can order the processing so that if you know that a certain system, not necessarily other like component modifications between each other, because that just can't happen. But if you know other systems are going to need to process something before a system down the line, there are a handful of update attributes that will order the processing of the systems. And so this can get around some of what you're asking as far as ordering, but it's really based on systems and not other components. And you kind of see this a little bit in Unity's own ordering here. Like, stuff is not just necessarily willy-nilly, is ordered in a specific way. And it's going to go down this line and process all of the stuff. If I have one on this, I don't. I thought I did at one point or another spawn system. No. But what you can see, I believe here, is my spawn system is going to be lower down. Nope, I lied. It's actually at the beginning, even though other things are processing about it. You know that Unity is a little bit automatically for you. You can specifically say, I want spawn system to update after tree reproduction system. It's doing some modification for it. The way that it's processed right here, it kind of doesn't matter by the time this is updated and catches back around. It's a single frame and it's not super important for my use case. Using those different attributes is one way to work with race conditions. That's what you're really getting after.
All right. Nick had a second part of that question, which I think you've essentially answered, but he asks, if two jobs require the same type of data, will they still run in parallel? Do we need to use locks around the data?
So expand on that further. You mentioned with locks, there are, if you notice here, I think, here it is. We have some components that don't have a coloration, some components that do. I believe that the ones that are gray are read-only. The ones that here are green, you can see are read-write. If we go into this bamboo growth system, we check out what exactly is happening. So that I've got my growth data, I've got my scale, I've got my bamboo tag. If we look, I am assigning a value to scale, and I am assigning a value to growth data. So Unity is kind of doing some automation for me, recognizing that these two are read-write. This one is read-only. If I remember correctly, this may have been updated. You can they have changed it. They've changed a little bit about the way this works. So I think I've shown here is a more updated version where everything is condensed into an update. Prior to this, they had it so that you created an individual class, and in that individual class, you could label some of these things as read-only. In fact, it was required. But with the update, they're doing a lot more of this processing for you behind the hood so that you don't have to worry about it. Yeah, Unity is doing a bit to help with these, recognizing what is read-only and what is read-write, so that there's already this process of identifying what type of things are being modified and using that to determine order.
Nick had a follow-up. As an example, what if units are looking at each other's path to make sure they don't collide? They'll change their own path to avoid each other. It may change as the other unit is looking at it. In this case, does ECS make sense, or doesn't it?
So, I don't have the best of answers for it, but I explored looking specifically into the nav mesh stuff for ECS, and I thought that stuff was not being done multi-threaded. When I did a little bit of digging, I found out through the profiler that it was. So that if you're doing any Unity nav mesh process, it's not in ECS, it is already going through jobs. That's the thing that I may not have pointed out in this, is that you can do jobs in monobehavior stuff, just that ECS goes ahead and organizes that data a bit better for you, so that it's not as difficult. You still have to gather all of the components that have the data and do essentially multi-threaded stuff in a authoritative monobehavior. Yeah, so Unity is somewhat handling that for you already, and I'm not necessarily sure how.
Okay. Nick says the read-write controls are helpful. I'll throw out one last question, and then we'll go into some mixed reality. So, Zane, there are some differences in how you have to think about this from traditional object-oriented. Were there any particular landmines you kept stepping in when you first made this transition, first started picking up ECS? Anything people should be aware of? Or anything that could make the transition even easier? Hey, Zane, are you hearing me?
Yes,
Okay,
I'm
sorry.
hearing you. Okay.
No problem.
There's... So, did you guys hear last statements?
No, after
Okay.
I asked if there were landmines or
Okay.
to ease the transition, did not hear anything.
Okay. We've only got a couple minutes. The question was about navigation. Essentially, if you're doing nav mesh stuff, Unity's doing some of that under the hood for you, so you don't have to worry about it. It is being done through jobs, just not necessarily ECS. We're out of time. Yeah.
Okay. Well, thank you
Okay.
very much, Zane. Post in chat where people
Thank
can
you.
reach you for more information.
Absolutely.
And a lot of good stuff. Very interesting look at, new way to look at coding. All right, everyone, join us in 5 minutes for some mixed reality. Really looking forward to this one as well from Jesse James Allen.